we only see the results.
Mm.
Like, okay, OpenAI has created a chat GPT and we are using it. Oh, the world has changed. It's something like that. But we have to see that these guys were working like from 2010s or early, more than 10, 15 years. These technology were in develop. We had no idea.
Mm.
When it comes on and we uses and then we tries to get into that industry. So the quantum computing is in that stage where like artificial intelligence were like 5 or 10 years ago.
Hi, welcome back to the JYU for You podcast, where you can learn more about our programs and student life at JYU. Today I'm interviewing Asif Mostafa, who's a second-year student in the High Performance Computing Master's Program. He's going to tell us about his journey from Bangladesh to Finland and why high-performance computing is such a relevant field. Enjoy! Hi, Asif. How are you?
Hi, Uliana. I'm fine. How are you?
I'm doing great, thanks. Thanks for being here.
Oh, thanks for inviting me.
No problem. So, can you introduce yourself and tell us where you're from?
Yeah, I am Asif Mostafa. I am from Bangladesh and I am here studying high performance computing, specialization in physics. That's a bit long name. But yeah, the program is called SPC in short.
Mm-hmm.
Yeah, I'm master's second year student, nearly about to finish my degree.
Nice. So, can you tell us a bit more about your academic background? Like, how did you get here? How did you find this program?
Uh, okay, so to answer this question, I have to get a bit deeper. So, in my childhood, I came across a very nice uh, sentence of a famous physicist called Brian Cox. The sentence is
Oh,
like,
I know him.
yeah, you know him?
Yeah.
Oh, yeah, he's a really nice guy.
Yeah, he's great.
Yeah, and he talks very well.
Yeah.
Yeah. So Brian Cox, I was not a very young person that time. I was very little, so but I could understand the gesture of the sentence, and the sentence is, um, what is it like to live a finite, fragile life in an infinite, eternal universe?
Oh my God, that's very deep.
Yeah, that's too deep, and for a child like me, it triggered me. So so from my childhood, yeah, I was so fascinated by this. So I wanted to study physics. Um, Apparently, in Bangladesh, there is from the university that I came from. It's University of Dhaka.
Mm.
So I there was a little bit of story of that also. It was um, back in 1920s, 30s, something like that. There's a famous physicist called uh, Satyendranath Bose. Have you heard the name of God's particle?
God's particle.
Yeah. Have you
No,
heard this
I have not.
fancy name?
No.
So okay, so this is the fancy name
Yeah.
uh, for God's particle. It's a particle who gives masses, who gives mass to an object. You know,
Oh.
when after the Big Bang, it was all energy. Then where this mass came from? We all have mass, right?
Mm.
So this particle is known as God's particle, and uh, the scientific name of it is Higgs boson particle.
Okay.
So this boson name comes from the Satyendranath Bose,
Oh.
who was who was a professor in my department very long time ago, from where I came from. So apparently there was a very hard admission test to get into the physics department on that university. So yeah, I got the chance and I got in, and this was the legacy behind. And by the way, Einstein himself wrote the recommendation letter to join Satyendra Bose to University of Dhaka.
Wow.
Yeah, that was so back of the mind. I knew these things, and I was like super fascinated. I will study physics, and yeah, and then when I started studying, I felt so dumb. But then again, I got into a university, so I have to take the degree, and yeah, I took the degree, but yeah, I was not satisfied at all.
Mm.
So, so after that, I thought, okay, let's be some people like that who earns money. So, what's better than to study computer science and engineering? Because
Mm.
that is like there are high paid jobs and sort of Amazon, Google, this sort of Apple, this sort of companies you can get into. So I thought about that. Let's become a money machine. So
Mm.
study this CSE subject. So I went on to do another bachelor in CSE. Then I wanted to uh, use both of my knowledge. So I wanted to find a subject where I can be and I can be in touch both of the knowledge that I have gained. So then I tried to find out that where I can get it.
Mm.
So I'll study physics as well as I'll study CSE also.
Mm.
So, um, uh, so then I came across this subject, which is high performance computing, and uh, and yeah, that's what the thing that I wanted, and I didn't waste any time to apply.
Nice.
Yeah.
Okay. So, can you define high performance computing to people who may not know exactly what it is in simple terms?
Yeah, yeah. The terms looks very like catchy. High performance computing.
Yeah.
It's actually rather simple. Mm, it's if I put it in a very simple way, um, in these days we need a lot of computing power for a lot of tasks. If you see these very massive machine learning programs, machine learning models, they need a lot of high high computing capabilities. uh, Many of the models we cannot run in our laptops or in our desktops. Why? Because the computing power is very less.
Mm.
So that's why the high performance computing things comes in. So we want to optimize. Say, suppose we have less computing power, but we want to run a program, a model onto that. So we want to optimize the program for that hardware. We as a high performance computing engineer, we we optimize the programs to get the maximum computing output. This is one of the tasks. There are vast area in high performance computing. So in our program, we study a lot about quantum computing.
Mm.
So, yeah. So I want to tell the audience that this is another big thing
Mm.
that people are trying to get in. If someone is interested in this sort of stuff, I will highly recommend, because if you see, we only see the results.
Mm.
Like, okay, OpenAI has created a chat GPT and we are using it. Oh, the world has changed. It's something like that. But we have to see that these guys were working like from 2010s or early more than 10, 15 years. These technology were in develop. We had no idea.
Mm.
When it comes on and we uses, and then we tries to get into that industry. So the quantum computing is in that stage where like artificial intelligence were like 5 or 10 years ago.
Oh.
So you will see a boom in like in next 10 years, probably, maybe.
Mm.
But then you would not know that it was on develop like this long. So it's a perfect time to get into this quantum if you are interested in quantum programming and quantum technology. Yeah.
Amazing. Yeah, let's talk about the facilities then. Like what facilities do you have available? What kind of systems do you have available in this program here?
Uh, so we have supercomputers. You get to work with supercomputers. You have to done projects in supercomputers here. We have excellent lab facilities for people who wants to go to any either of the paths. Um, as I am in the physics path, so I can say um, there there are labs with with high precision devices which are very costly and which are state of the art. Uh, we have a Blue Force cryogenic system, which Blue Force company is one of the top in cryogenic systems. So Google use Blue Force cryogenic stuffs, these refrigerators, and many other companies. So we have that, and yeah, I can go on. The lab facilities and the facilities, if you study here in high performance computing, you get state of the art facilities here.
Amazing. And I'm curious, what do you do specifically in the lab? I know you have a project going on. Can you tell us more
Yeah,
about it?
yeah, sure. So as I said that I moved to the physics specialization.
Yep.
So my work in the lab is is cryogenics engineering. So what is that? It is studying uh, the chips, superconducting chips with very low temperature. We are talking about 50 millikelvin, 40 millikelvin. I mean this. If you get to there, 40 millikelvin or 50 millikelvin, I can put it straightly like this. This is one of the coldest place in the universe.
Oh my God.
So yeah, one of the, because we can go to absolute zero, right? It's minus 273 degrees Celsius.
Wow.
So we do these chips, we do these measurements in the coldest amount of temperature is possible. So that's how these chips become superconductive, and my work is uh, so these temperatures are achieved through refrigerators.
Mm.
Yeah, the refrigerator that is at the home, yeah, that maybe cools down to some degrees Celsius, but these refrigerators goes down to quite deep. So there are basically three types of refrigerators. It's one of them is called PDR, um, which is kind of a bit older technology, but it still cools pretty well. We're talking about 4 Kelvin. Um, One of the PDRs in our lab goes to 50 Kelvin. But then there are another set of refrigerator which is called ADR, adiabatic demagnetization refrigerator. So that's where I work.
Mm.
Actually, my work was to uh, set up this ADR, and to develop all the lines through the output, and test this chip, which is SQUID, superconducting quantum interference device, to characterize this, to find the properties of it. I'm going very surface level, but yeah, that so it took like 6 months for me and for my supervisor to set this experiment. uh, Then I took the data up until now, so I'll work on that data in this weekend. Anyways, so that's my work, and there is another refrigerator which is called, as I said, which is Blue Force state of the art refrigerator. Uh, it cools down to 7 Kelvin, which is very near to absolute zero. There is another set of people working on superconducting qubits, which are the fundamental qubits for the quantum computers. You see,
Mm.
so it's directly connected to quantum computers.
Interesting. What I'm
Yeah,
hearing is that it's everything is very high tech and amazing what
yeah,
you're doing.
yeah.
And I'm curious, are you using that data also for your thesis?
Yes,
Okay.
yes.
Can you tell us a bit more about what is the thesis process like in high performance computing? Because from what I understand, like you were saying, it's a very multidisciplinary program.
Yeah,
So you can either specialize in chemistry, physics, or computer science engineering.
yes.
So I imagine that there are many possibilities of what to do
Hmm.
in your as your thesis project.
Yeah.
But can you tell us more about that?
So for me, the for in the physics area, you can do this as I started in the trainee in the lab. So I worked in superconductivity, which is the hardware stuff. It probably in future will relate to the hardware preparing for the quantum computers.
Mm.
Then this is my thesis, and if you don't like hardware machinery stuffs, and then you can go for thesis in like software, quantum computing softwares, sort of like that quantum programming. So there is a lot of vast amount of opportunities to do thesis in like wide different areas in CSE or physics or chemistry, which is fascinating.
Yeah, that's incredible. It's very multidisciplinary and very
Yes.
very broad, but then you can go deep into what you
Yeah,
specifically want to go into. That's really interesting.
exactly.
And then related to that, I wanted to ask about your plans after graduation, if you have them, no pressure. um, and more about like what sort of careers can come out of this degree.
Yeah. So let's talk about the careers that can come out from this degree. Uh, yeah, there. If you are like very good at study and you are passionate enough, I would say the careers in this field is like sky is the limit. I mean, you can go anywhere if you target for the top tech industries, Google, Microsoft, Intel, whatever you name it. Uh, you can go there also. You can start your own startup. You will work in as a machine learning engineer or artificial intelligence engineer or HPC engineer. You can work in the hardware stuff. You can work in the software developing stuff. The optimization engineer, you name it. I mean, these all fields are open for this program. If you are like have the necessary skills. Uh, so I would say that there is a very bright future for this program if somebody has the necessary skills. And then again, these programs, as I said, that these programs leads you to the state of the art technologies. It's like quantum computing stuff, which directly connects to this program, and we have mandatory courses of those like quantum programming, quantum computing, this sort of you have to take these courses. So this aligns with the state of the art technology that we're gonna use in future. So yeah, there are vast amount of career opportunities in this program. And talking about my future plans, well, I want to be a researcher, as I said. I want to be a physicist. I don't know. I think I can do it. Let's see.
Yeah.
But yeah, I want to go to the hardware stuff for researching in quantum computing. So yeah, that's the plan I have in my mind in future, and my present expertise, the training that I am having in the lab, aligns with that path. Yeah.
Amazing. Yeah, and then speaking about for people who are watching us and maybe thinking of applying, Who do you think this program is best suited for? What kinds of backgrounds do you think are helpful when joining this program?
So a future candidate who wants to apply, he should learn some basic programming skills. He should have that. Um, um, then it will be easier for him if they can get the chance. And the person who are interested in computer science and state of the art technology in future, I think that is perfect for them. And the people who studied physics and they uh, also want to study not only physics, it's the natural science, and they want to study in CSE also, computer science, IT. So this is a perfect blend. This program is perfect blend for them. So if somebody is from the background from physics and chemistry, and this program will boost their this the ability to work in those fields also. So these are the perfect candidates, I think, for studying this program.
Great. And then last question is, what advice would you give for somebody who's like considering coming to JYU to study high performance computing?
Yeah, uh, I would not give them any advice. I will probably encourage them,
Mm,
yeah, to come here. And if they're passionate enough to study in CC and pure science related stuff, I would definitely say this is the perfect blend for all this. For getting into the tech industries, to get into the researching area, to get into the pure science background. I mean, this program gives them a perfect blend, so they can choose it without any hesitation if they're passionate enough.
great. Thank you. Thank you, Asif, for coming and sharing your experience with us. And yeah, see you around.
Yeah, thank you so much, Juliana, for inviting me, and see you around too.